All right, welcome here. We prepared a couple of questions, and maybe later the audience can also ask questions. As I said, this task force is here to do two things, basically. One thing is on the marketing side, to get the word out inside the LoRa Alliance, but also inside the IoT ecosystem, that energy harvesting is the way to go. These companies here actually have products that are energy harvested and are LoRaWAN based. Maybe next year we'll have a wider audience with other wireless protocols, but these three companies have LoRaWAN sensors that run on energy harvesting and different sources of harvesting. So the first is Dániel Hollós from Dryad, welcome. Tim Cooper from Semtech.
Hello.
And Lyubomir from MClimate, welcome.
Hi.
So, first question I'd like to ask to Dániel. So, I mean, Dryad provides an early detection system for wildfires. It's needless to say that these devices will have to be based on energy harvesting in the woods. Can you talk about the reliability of these devices out there in the woods?
Yeah, sure. So at Dryad we build end-to-end ultra-early wildfire detection systems, both the sensor as well as the gateway systems. And the gateway systems is meant actually to provide communication infrastructure on the remote areas in the forest as well. And the big challenge we face from the energy perspective at the sensor is actually not the LoRaWAN communication, but the fine sensoric needed to detect the fire in its very early stage. So in practice, these sensors need to smell the air constantly to catch the very light density of the smoke produced, the forest fire in the smoldering or the pyrolysis phase, and that takes approximately 99% of the energy budget of the sensors. So that's on one hand. On the second hand, on the other hand, we periodically do a large-scale data collection in the sensor readings and send that to the cloud to train our machine learning systems. And then photo periodically the sensors also to get the results back to the devices.
Okay.
So that's on the sensor side, and this covered by a fine-tuned power management system actually ensures a pretty safe operations also over several cloudy days, so extended periods of operation. So the system runs on solar very nicely. Now on the gateways, very briefly, we also cut down the energy consumed to the edge, I would say. We have a customized hardware, rewrote the software, we run it on an ultra-low power MCU, so we are at a few milliwatts on average, which is industry leading, yet it's not enough. It's not sufficient to run on any kind of battery packs at the moment.
Yeah, I think to the technical side of things, we, in the task force, we'll get to that next year. There might actually be optimizations to the LoRaWAN protocol, as Zigbee did, as 5G did. They made modifications. And actually Dryad has deployed their own mesh network, right, for LoRaWAN. That might be another way to actually leverage energy harvesting. Thank you for that. Lyubomir, you guys already have several sensors on energy harvesting, and you have the same sensors also available on non-harvesting, so batteries.
Yeah.
What would you say, talking to your customers, how do they perceive the benefits from an energy harvested room sensors?
Yeah, just yesterday, one person said, can you please remove this black rectangle from the sensor? We're going to just run it on batteries. So I guess the market wants what it wants. I would say energy harvesting is not easy. It is very challenging. Of course, there are innovations and good job on the 40% increase. But still, for me, energy harvesting shows that, okay, the manufacturer knows how to optimize energy consumption of the device. But then it's not only such challenges. There's also the challenge of actually the customer willing to invest into this. So sometimes we have customers that are, pretty easygoing. They say, well, we know there's some dark rooms, so that's fine. We're gonna visit again and move location. But for some customers still, they just decide they prefer to keep the batteries in or even get rid of the energy harvesting. So it's a little bit confusing, but I think it's nice to kind of have options for both. Because we saw the same thing with displays. Some people want the display, some people don't. For energy harvesting, it is a lot of investment from our side to improve the hardware, to obviously keep the firmware using as low energy as possible. But it is not so nice that it brings this uncertainty into the installations. Because when you have batteries, you just put it, it works, that's it.
Yeah. Okay. Thank you. By the way, these two companies already have released interesting blogs that are available on the LoRa Alliance website. Coming to Tim Cooper, I think you're going to release an app note either today or later this week.
Yeah.
So can you tell about sort of Semtech's perspective on energy harvesting, given that LoRaWAN protocol is already very low power, and how it's well suited for energy harvesting?
Yeah, absolutely. So the app note that we've done is a kind of feasibility study, hopefully to help try and convince some of your customers, Lyubomir, that energy harvesting is viable. So we put ourselves in a pretty challenging scenario. So we had 200 lux environment. We have only 8 hours of light a day. And what we found in that scenario, just using commercial off-the-shelf components, so 45 millimeter by 45 millimeter energy harvesting PV cell from you guys, using EP's energy conditioning, using just a supercap off the shelf, Murata module, the 2GT module that actually features the LR1121, that with just those basic building blocks, we're able to send every 90 minutes a full LoRaWAN uplink, open the receive windows, and that all functions perfectly, basically. So there's really, with the LoRaWAN as it is today, that sort of Class A uplink, I think in that scenario, we actually end up with sort of 30% more energy than we needed being delivered in that environment. So I think LoRaWAN as it is today, just for sort of Class A uplink, is already quite well suited, as we've seen with Dryad's applications to energy harvesting. So yeah, we're all set for it. Not to say there aren't improvements necessarily elsewhere in the stack and things we can do, and that's what the task force is about.
Okay. I think you're also creating some sort of a calculator or...
Yeah, absolutely. So in conjunction with that, yeah, it'd be interesting to create a sort of an energy harvesting calculator that will complement our existing LoRa calculator as well. Yeah, absolutely.
Very useful for those who consider to design an energy harvested product. It is not completely trivial, as we all know, in designing energy harvested products in terms of optimizing the power. Coming to you, Dániel, if you would anticipate maybe how a LoRaWAN protocol could be optimized for energy harvesting, do you have any specific ideas there?
Yeah, sure. In my view, the increased availability of energy harvesting devices will call for also higher range, longer distances, and that will call for a more advanced coverage extension methods in the standard. But there are also examples from the industry today. For example, in building automation systems, it's often not practical to deploy with LoRaWAN, actually, due to the large number of gateways needed for this. And at least at the moment, the gateways need a mains power and internet connectivity as well, and it increases the maintenance costs a lot. So with whichever methods, the standard will evolve, either introducing maybe multi-hop support for relay D2D, or maybe allowing some multi-hops for the gateway-to-gateway systems would be, of course, most than welcome. It would be very useful for covering these use cases. But not only the daily operation needs to be improved in the coverage extension, but these methods and these new standards must fully engage for the FOTA as well. Because at the moment, the FOTA is a bit vulnerable, especially fragile for devices which lay a bit further away from the gateways, so that the success rate is not always so good. And especially, it's prohibitive for very small devices. So that needs some discussion, in my view.
Yeah.
But coverage extension with FOTA would be what I would like to see.
Yeah, so having said that, I think right now there's 30 companies member of this task force, LoRa Alliance, for those who are a member. Please join the task force because I think there's several benefits of being part of it. We have here 3 gentlemen that are very active in supporting the task force. So Lyobo, in terms of when you joined the task force right at the beginning in May, June, what would you say are benefits for a member to be active in the task force?
Oh, to me personally, it's like talking to like-minded people that are not direct competitors as well. So we can also sit and pretty openly discuss, positives and negatives of different things. We can share some knowledge. We can also draft some articles to educate the market, obviously. when you said you did a case study which would maybe persuade my client, well, if the client is like a facility manager with big hands and yeah, maybe he's not going to be persuaded, but I think what we're doing is important. I think a lot of greenwashing also happens in energy harvesting, obviously. I don't think we're at the stage where you can do everything with energy harvesting, obviously, but I'm happy to be part of a like-minded group of individuals that we can just share openly and try to influence how the technology goes in the future.
Right, fair enough. Tim, question for you. From a technical perspective, what would you say are the key challenges for doing a redesign or a greenfield design of an energy harvest device? What are the 2 or 3 main things to watch out for?
Yeah, so I think from the work we did on the application note, the thing that we saw, there's obviously for any energy harvesting design, if you're going to come from batteries, then there are sort of 3 things that ordinarily you would need to do. The first is obviously identify the right harvesting technology. Secondly, add whatever signal or supply conditioning and storage you need for that. And then in a lot of cases, the third thing that you would need to do is then optimize your communication to ensure that it's sufficiently frugal that you're not going to completely use up that energy supply. I think the advantage that we've got built in with LoRa in many ways, I'm talking about end device to gateway communication here, is that communication protocol is already really well suited to energy harvesting operations. We have metering customers already in the space that have average consumption in the microamp range. I think for the application note we had 11 microamps of average consumption, even supporting like SF12. So I think we have a communications technology here that's very frugal by design, on top of the radio technology that Semtech brings. That really gives us, I think, what makes that third step easier of making the communication protocol and the communication process energy harvesting friendly. So the 2 other steps I'll leave to the experts, but for the communication side, I think we're already pretty well in pretty good situation.
Excellent. I think I'd like to open up for questions from the floor. Anybody wants to ask the panel a question? Carlo. The microphone's coming.
So, Carlo Tinella from Semtech. Lyubomir, question for you. You mentioned customers that asked you to get rid of the solar panel. Okay?
Yeah.
But do you know why? Is it because of aesthetic, let's say, feature? Is it because they are not buying the value of not having to replace batteries? And cost-wise, they are not making the, let's say, the business case?
Yeah, it wasn't cost-wise.
Or reliability? Or maybe they
I
don't
think
trust.
it was, the use case was an office, and they just didn't want to have solar panels. They said, that's great, but we don't care about the price. We just don't want to have a black rectangle saying organic solar panel. So maybe it's something connected with, for example, having a CO2 display in the office or in some place. Some people, we make a device with a display and then they say, can you hide the CO2 level? So I think it's just a preference of the customer. I think LoRaWAN already gives a great promise, and it is very long battery life. When you do this inside buildings, it's really easy to go to SF7, and then it's really easy for a quality engineer to achieve 10 years of battery life with some obviously good quality batteries, right? So I think this specific reason was aesthetic and not their willingness not to show, so to say, the solar panel. Yeah.
Clear?
Thank you.
Okay. Any other question? Then I think I can close here. Thank you very much for the attention here, and look forward to see you soon, and maybe soon, happy travels.
Yeah.
Okay.
Thank you.
Thank you.